to the RCA Institute's June discussion. This month, we're going to talk about RCA in actions, its application in actual companies. At the beginning of this presentation, I will take a few moments to introduce those of you who may be new to RCA and RCA modeling. As always, I'm recording this presentation. At the end of the presentation part, I will stop recording and open it up to any of your questions, comments, or other discussion items. By the way, if you have think of a question in the presentation, don't hesitate to use the chat or question feature, and I'll look at those when I finish. So I always show this slide. This slide talks about what RCA is in the biggest sense. RCA is a combination of German management and costing methods known as GPK or Grenzplan-Kostenrechnen and activity-based costing. If you're not familiar with GPK, don't feel bad. It's not widely known. It's been around for a long time when the controlling profession in Germany was largely developed within the operations area, not within the finance area. And so therefore, it's very focused on capacity analysis and management. RCA's goal is to create an economic model of operations for decision making. So to that end, RCA focuses on internal decision making, linking operational metrics to finance, and reflecting clear cause and effect relationships in that model. This was a IFAC document put out as a white paper on costing continuum and levels of maturity some years ago. However, as you can see in this evaluation, resource consumption accounting was rated as the most comprehensive method of costing. Just short of full real-time simulation. And I would argue, and perhaps you'll agree when you hear the rest of this presentation, that you'll need to use RCA techniques to achieve full real-time simulation in an accurate and causal manner. Let's talk about the RCA modeling approach. I break it down into 3 steps for simplicity. It's probably more complicated than this, but I think this will give you the idea. First, you model the resources, their capacity, and what consumes or uses them. In other words, linking them to the value they create. Next, you model the flow of resources, quantities consumed, and the nature of that consumption. And by nature, I mean fixed or proportional consumption. Or if there's another form of relationship, it's possible it could be inverse, but normally fixed or proportional. And what you have after the first 2 steps is a cause and effect operational model. The third step in an RCA modeling is to model the costs that flow with the quantities. And of course, the nature, ensure those costs reflect the nature of the consumption. Let's look at a very, very simple example. So step 1 is you model the resources, the capacity, and the consumption path. So in other words, you're looking to show what value they create. Now, keep in mind, RCA is about decision support. So RCA isn't limited by GAAP definitions of product cost or inventory cost. The other thing is, you should notice there's a lot of things missing. We're only dealing with direct materials, plant labor, and plant maintenance. There's all kinds of things like marketing, sales, distribution, warranty support, financing, all kinds of things. And I know that. We're just trying to give you a simple example of RCA model. So step 2 is you quantify the flow of the resource quantities and the nature of the consumption as fixed or proportional throughout the organization, and you do that in operational quantities. So I want to emphasize there's no money here. Right now you have a cause and effect model that now we go to step 3. And we bring in money. So now you have the finished model, which has the quantities and the money. And you have some information that you can use to present a monetary model. Now, what we normally do with this is create a multi-level P&L that accurately reflects the marginal costs of the resources consumed and properly assigns those costs to where they create value, or in the case of things like excess capacity or other non-causal costs, to a level where it is most appropriately managed. The important point I'd like you to take away from this is that RCA focuses on operations and operational data and ensuring that's reflected in money in a logical, causal manner. So let's look at some applications here, which is probably the reason you attended this webinar. So first we have a plastic film extrusion organization. They had a number of problems prior to starting to use RCA. Their product costs fluctuated based on unrelated changes in volume and mix. The products that were manufactured on newer machines received greater cost allocations, even if the products were identical. Old machines were fully utilized and new machines were underutilized, even though the new machines were much more efficient. And sales reps were able to lower prices non-strategically to increase volume in an effort to decrease the allocated cost per unit. And this, in the way that structured the incentives, improved their margin, and their compensation was based on, in substantial part, their margin. So they were playing with financial accounting costing, not reality. So what happened after RCA was put in? First, the product cost is stable, even if an old machine is replaced by a new one. This was done by applying replacement cost depreciation, or if you will, a capital preservation allowance, and proper construction of resource pools so that there was no advantage to the older machine. Also, there was causal assignment of costs. So non-causal costs were not assigned to product cost, and that eliminated a great deal of the distortion. So fixed costs were no longer assigned, fixed costs no longer change due to volume and mix because they're handled correctly in the model. They're handled as fixed costs, not variable costs. And as a result of all this, the margin manipulation by salesmen was eliminated. And it was shown that standard costing had actually overstated fixed costs assigned to product. The next little application is a South African platinum mining company. And now this company had spent a lot of money putting in place a strong manufacturing enterprise solution for their operations. And as you can see from this dashboard, and it's kind of hard to read, but they had numerous operational metrics, and their supervisors were trying to meet a performance standard that was set by everything, all the equipment and all the processes operating at what they called an ideal state. The problem was their supervisors were coming up with different ways to meet that. Some of them would put more energy into their crushing. Some of them would add more water to the crushing mix. So they did various different things. And there was a lot of debate among those supervisors about which one was most effective. And the reason for the debate was because they didn't know the cost impact of their various operational strategies. So what was done was an RCA model of the production of the operation was put into place. It was very near real time, refreshed itself every 5 minutes based on what it was viewing in terms of actuals. And what it generated was an opportunity cost. So we ran what they called the optimum operating envelope, that stretch goal, where if everything was operating, all the equipment and resources were operating perfectly, and we came up with that as perfection, and then there was any gap between that and where the performance was constituted an opportunity cost of operating below that optimum envelope. So that allowed all the production supervisors to test the cost impact of their various strategies and eliminated a lot of debate and contention. The next application I'd like to show you is a catalytic reduction system manufacturer. They wanted a real-time dashboard of the key KPIs to allow for quicker reaction to operational performance issues. They wanted to focus on KPIs that were in fact financial performance drivers. They wanted to be able to drill down into both operational and financial detail and simulate the financial impact of potential changes to operational and financial key performance indicators. So this screen shows a bit of their model. It shows the major cost centers within the company in the left-hand column. And as you will see later, this column has a substantial drill down capability to resource pools and resources. The plan or budget is the next column. Then the actual, what's actually occurring to date. And finally, the target is what the actual should cost if the plan were extended. In other words, you're running through those those budgeted numbers to the actual activity achieved, because in essence, it's a flexible budget, because you don't want to turn away business just because your budget said you're only supposed to go this high. And of course, over on the right is the actual output associated with those cost centers. Now let's drill down, because if you remember on the last slide, the forming cost center was showing a red indicator, indicating that there was a problem with its cost performance. So when we drill down to the actual resource pools under the forming cost center, we find there are 5 resource pools: extruder, forming, pre-extruder, chiller, and washer. And we see that the extruder is causing the red mark. So again, you see the same columns: plan, actual, target or flexible budget, and then the capacities. And we'll drill down again. So now we've drilled it down into the extruder resource pool. And we see the primary costs, which, if you'll remember from other discussions of this nature, primary costs are those that are in the resource pool, and secondary costs, which are resource pools that support the primary resource pool, or the extruder resource pool. And we see that, in fact, it is the maintenance resource pool that's passing along based on causal activity, assigned costs that are pushing the extruder to show the red indicator. This screen contains a lot of data, so I just want to spend a moment going over it. The first 3 columns are, again, your plan, your actual, and the variance. Oops. And or the plan, the actual, and the target. Then you have 3 columns over here with some sub-columns that are a little bit different. We have fixed costs, we have fixed proportional costs, and proportional costs. Now, what's interesting about this is really the fixed proportional cost. What RCA is able to do is it tracks how costs change as they go through a process. So what you see is that some costs start out as proportional, but by virtue of the way they're used, they become fixed. And that's what the fixed proportional column indicates to you. And it's information that really isn't available, but it's a phenomenon that's sometimes been called the snowball effect of fixed costs, and how costs tend to become more fixed as they move through a process. And RCA actually shows how and where this happens in your model. The final slide I want to show you here about the extrusion, about the extruder, is this element of simulations. And they wanted to easily be able to say, what happens if we improve our various efficiencies? So this one shows the actual, this one shows the simulation. And what the idea is that you click an arrow. What if we invest in a project to make this this particular efficiency metric better, or if we don't do something and allow it to become worse? What's going to be the operational and cost impact associated with that? So this is a very simple analytical tool, but in order to be able to do this, it has to reach deep into the model, both the operational model and the financial model, to do this accurately. So I hope this presentation gives you a sense of what an RCA model can do. Most of these, I think all of these were manufacturing examples. These are the ones where we're allowed to show data. RCA is used in services, medical providers, software development, maintenance, government. We just don't have permission to use that data. So I'm going to stop recording